let's get some experience with R. Let's get some data into R and do a very brief introductory sort of analysis of the data. We're going to use box plots in order to do that. All I'm going to do now is show you how to get these data into R and then construct the box plots and find the quartiles in R. So what I have here open is a copy of Excel, and I have in these columns over here, I have animal name, sex of the animal, and the weight in grams of the animal. Notice a couple of things. First of all, every name, there are no spaces in these names, and there are no numbers, so everything is just letters, right? No numbers. Same is true here for sex. It's just M and F. Later on, when we begin working with data, these are going to be zeros and ones instead, and there are all sorts of statistical reasons for doing that. For right now, we'll leave it as M's and F's. And then these are the body weights. So what I want to do now is save these data in a form that's going to be accessible to R. The way I'm going to do that is I'm going to simply go up here to the File command and save as, and I want to save this on the desktop. And that's where it is right now, and it's called NSF data, or NFS, so Northern Flying Squirrel data. And notice here I have it specified as a CSV file, so that's column separated values. It's just so much easier to work with those sorts of files in R. We could also have it as a text file, but it is easier, or even as an Excel file proper. But this does make things easier, so I'm just going to hit save. And it already exists. That's fine. I'm going to replace it. That's good. And I can now close it, and we are ready to go. So now here I have is my console for R. On the left-hand side is the console. On the right-hand side down here is where all my graphical information is going to show up, and up here is my what's referred to as the environment window. The first thing I'm going to do is type in a command here, RM, which stands for remove, and then I'm going to ask R to list, okay, list, let's see, what exactly, list equals, and then ls paren like that, okay? So what I'm doing here is I'm asking R to remove, okay, and then whatever's in here, and what's in here is I'm asking it to list, right, this ls, that's a list of everything that's in the memory. So essentially all I've done is clear the memory of R from any previous sessions. So now I'm going to use a hashtag and just have some comments up here that aren't going to be interpreted. So this is experimental design example. Let me say design box plot example. All right, so now I have a little definition for this script, or a little title for this script. The next thing I want to do is actually get these data that we just saved into Excel, or into R, and the way I'm going to do that is by defining a new data set, and I'm going to call that data set NSFWTS. Okay, so space, and then an arrow and a dash, and now I'm going to say read.csv. Okay, and then paren, and I'm going to use choose.file. What this does is it forces R to provide me with a dialog box that'll help me select the file. And in doing so, the path to that file gets incorporated into R. Otherwise, I have to specify the path myself. So choose File, and then I'm going to use comma and a new command, header equals T. So I'm telling it that the first row of this data set has a header. That's a true statement. T stands for true. If the first row of the data set did not have a header, I would have to say header equals false. So now I can hit that enter, and I've got an error. Choose.file, what have I done wrong there? File.choose, so let's fix that error. Okay, so NFSWTS less than arrow, right? So read .csv, okay, and then paren, and now I say file dot choose, paren, and then comma, header equals T. All right, now I'm going to have a dialog box open. Let me go grab that dialog box. So here then is my dialog box. There it is, NSF data. I'm going to click on that, hit open. And now you can see up here in the environment that there's that data set right there. Okay. So now what I want to do is I want to make sure that I have it, take a look at it. So I'm simply going to type in NFSWTS, and there's my data set. So I have 16 observations. This is the animal name, that's the sex, and then there's the grams. So now let's make our box plot, and all I'm going to do is I'm going to type in box plot, and then I have to specify which file I have. So I'm doing this for NFS weights, and that isn't exactly what I wanted, right? Because now it's giving me for animal sex and grams. So that isn't the answer that I want, right? So let's fix that. So what I have to do is I have to be a little bit more specific. It did exactly what I asked it to do. It created a box plot for all of my variables. But what I want is not for all the variables, but simply for the column called grams. And grams object is not found. Okay, so the what we need to do here is include a statement that says attach, and now I want to specify NSF weights. Okay, now let's try the box plot. Using grams. And there we have it. So here now is our box plot for grams. And there is a nice feature here. I can take this and I can export in whether I want to export it as a JPEG, a TIFF, a bitmap, or a SVG file. I can do that for inclusion in a publication. I can also put in labels and titles and whatnot. For right now, we're just going to leave this as it is. But let's take this one step farther here, and instead of just getting that nice pretty drawing, let's also get some preliminary information from this box plot. So what we want to do now, if I can ever get this cursor over there, there we go. I want to type in quantiles So quantile, paren, and then this is for grams, and then comma, and then PROBS, so probs, and then equals C, and then paren. So I want the quantile, so I want the 0th quantile, which is going to be the minimum, the first quartile, which is going to be 0.25, right? Then the median, which is 0.5, the third quantile, which is going to be 0.75, right? And then the maximum value, which is going to be 1. And I now have this table, which gives me the minimum body mass is 128. The first quartile is 169.5 grams. The median is 179.5 grams. The third quartile is 206.25. And then the maximum value is 305. Okay, I've added another line of code here. You can see that right here on the bottom. Just box plot grams, comma, main equals box plot. So that's a label across the top of the graph. And then a Y label, YLab equals grams. So here you can see I have grams, box plot across the top. Okay. The next thing I want to do is I want to subdivide the data into males and females and put side-by-side box plots. Okay, just one more quick change. I've redone the box plot, and this time I've added one more command here at the bottom. So box plot, it's the same as I had before, but I've added this LAS equals 1. And you'll notice what that does is that has rotated the labels here on the y-axis. Okay, let's now begin and put in the side-by-side box plots. Okay, so let's now create the box plot. We want the side-by-side box plots, so box plot, and this is going to be grams. And now, though, I want one little addition here, and I'm going to use the little tilde symbol. If I can find that on my keyboard, it's around here somewheres. Ta-da-ta-da-ta-da. It's got to be there somewhere. I know it is. I use it all the time. There it is. All right, there's my little tilde symbol. And now I'm going to use, what did I call that? That was sex, right? So sex, and hit enter, and there on the right hand side now you see the side-by-side box plots, females on the left and males on the right. And I could then go through the whole exercise of putting labels and rotating the axes and so on. I will leave that up to you. But just a few comments about what these box plots are telling us. Okay, so as we indicated in our discussion, this heavy line in the middle is the median. So half the observations are above, half the observations are below. You can see that for the females, the median is not central, right? Here the median is pretty evenly distributed between the two quartiles, right? Here it's not. So what that tells us is that the females are skewed to one side. Okay, so here's the minimum, there's the maximum. That's a little bit different than the traditional way of computing these limits here. Traditionally we use adjacent values, but that's difficult to code for, so we're just going to go with max and min values right there. Up here, you see this, well, that can't be, so that does have to be the adjacent value, right? So there it's going to be the minimum, but there it's not. So that what that open circle up there is a mild outlier. So that occurs with a probability of 7 out of 10,000. Here I have two mild outliers, so one outlier below, one outlier above. So if these data were normally distributed, I would have, for a data set this size, there would be no outliers, mild or extreme, and my quartiles would be evenly distributed between these adjacent values, and then the median would be central within that box right there. For the females, that's not true for the males. So the data are not normally distributed, right? They are skewed. They're not normally distributed. But that gives us a nice, easy way to get a sense of what the data looks like. Of course, we could transform the data and force it to be normal, but for right now, this is all we really need to accomplish.